Hi, my study analyzed treatment of mice with Down syndrome. Researchers wanted to understand if glutaminergic or GABAergic pathways were the ones that hinder brain function in those with Down syndrome. And this is significant because it helps us to identify which synaptic markers are causing synaptic inhibition in humans with Down syndrome. This was done by professors from Tufts University and the University of Paris. So what they did was they got 4 groups of 3 to 4 month old mice. 2 groups were the control groups, 2 groups had Down syndrome. One of the Down syndrome groups had DYRK1A, the other had TS65DN, and both of those are the mice equivalent of humans who have Down syndrome that affects chromosome 21. So over the course of 4 weeks, the mice underwent EGCG treatment, which is where every day their food was injected with green tea extract and some other supplements. And throughout the course of the 4 weeks, the mice had to do timed Y-maze tests because researchers wanted to see if the speed that they performed those mazes would improve and they would get to the reward faster. And those were the behavioral analysis tests while they were alive. After the 4 weeks, they were euthanized, their heads were chopped off, and the tissue was immunoblotted, and those blots were rendered to digitalized images. The researchers studied the cortex, hippocampus, and cerebellum. What they found was that in mice with DYRK1A, the GABAergic markers were lowered, but the glutaminergic markers were raised in the hippocampus. So this demonstrates that EGCG had a rescue effect in the hippocampus. What a rescue effect means is that we started to see improvement in signaling, and there was less synaptic inhibition. Low GABA levels means low inhibition, elevated glutamate levels means more signaling, and so we were able to see that these mice got closer to the levels that the control groups were demonstrating. Likewise, TS65DN mice had EGCG rescue levels in the cortex and hippocampus, and as a side note, the TS65DN mice performed better in the Y-maze than DYRK1A mice. So researchers wanted to continue this study and see if they could test the human equivalent of EGCG treatment on the mice. So instead of EGCG treatment, they received MGTE treatment, which is very similar, but the ingredients were adapted to fit human consumption. And so over the course of the 4 weeks, the researchers tested different varieties of dosages, one that was lower, similar, and higher than the EGCG dosages that they received. And so they were given them daily over the course of 4 weeks, just like the first trial. And similarly, they did have to do a maze, but this time it was a spontaneous alternation paradigm. And again, side note, here DYRK1A mice did better because there's a genetic component that helps them with short-term spatial memory working. And so after the 4 weeks, the mice were euthanized again, same process, immunoblotting, and here they found that the GABA was rescued when they used the high treatment of MGTE, and the glutaminergic levels were rescued with low levels. So the researchers decided to compromise and say that the intermediate level of dosages had the best effect on the mice. Now, what this would mean for humans is that MGTE could rescue both GABAergic levels and glutaminergic levels in, pathways in humans if given a sufficient dosage, and that the ingredient that rescues your synaptic inhibition and prevents it, or at least hinders it, has been right under our nose. It's green tea extract. What this also would mean is that if given the treatment, humans can have better signaling and can have higher brain functioning over time. These researchers want to move on to human consumption, and they think that it's very likely in the foreseeable future because these are grocery store household ingredients like green tea and other extracts from natural plants and teas and things like that. So thank you.